Okay, so let me start with a question. How many of you are data scientists or have experience with hands-on coding with advanced analytics data science? Okay, that's roughly a third, I would guess. And how many have experience in managing data analytics projects or data science projects which were not in research? Okay, 4, 5, not too many. So that's good for me to know where I should focus on. So when I did my PhD, I had the opportunity to bring advanced analytics into a big bank in Switzerland. The topic was employee fraud detection, so they needed some more advanced methods to tackle this problem. And the PhD was therefore not so much about developing new algorithms and then writing papers about it, but to develop new algorithms and put them into work in the company and see what the effects are. So on the one hand, I had these interesting problems of developing algorithms, see where the limitations are of current algorithms, and push the boundaries there, some theoretical data science stuff. And on the other hand, I struggled with all these quite easy, so to say, problems, like people did not really know what I was doing in the bank. There was a really strict IT landscape, so I needed to work around this and integrate my solution somehow. So this was when I became interested in what does it really take to make data science work in the real world. So all these different aspects, different problems that you see there, which could have the effect that things are brilliant, or you have brilliant models, you have machine learning, you have AI in place, but it does not really generate value. And that's, of course, what I would like to talk about today. So fast forward after my PhD, that was 12, 13 years ago. I'm now head of analytics and AI in AWK. And we have quite a big community. Roughly in these 3 companies, we work closely together. We are in one group. We are 150 people working on all kinds of projects with analytics, AI, business intelligence. So we have seen a lot of projects, lots of situations, lots of failed investments, lots of successes, of course, hopefully. So I think I have the experience to tell about these stories. Now, a random statement from Gartner, which makes it obvious that this is still a problem. They say roughly 20% will fail to deliver business added value. And what I want to tell you today is how you can join this big group of failures. But of course, it's not about the failures, but it's about recognizing these situations, recognizing these positions of people to avoid them when you do future projects. Because chances are really high that no matter if you're a data scientist or not, one day in your life or lots of days in your lives, you will work in projects that have some data science in them. Okay? Now, for a start, let me quickly talk about how we see this data to value transformation. That's all about in data science projects. You want to have the data, you want to make value, at least in the real world. So first of all, you need to identify what do you want to invest in, what do you want to work on, where are the problems that you can tackle with data science, with data analytics. Then, of course, you have to make sure that as a company, as an organization, you are ready for this. You need some data, obviously. You need all the infrastructure, you need the skills. You need to know what you can do with the data without being illegal. you need some governance, you need some processes, and so on and so forth. And then comes the fun part. This is the proof of concepts, prototypes, where you use analytics, machine learning, AI, to evaluate the potential that you first thought is there. Ideally, in the end, when you have done your POCs, you have a business case that shows, okay, if we solve this problem with the models that we built and we put it in production, the return on investment will be positive after a certain amount of time. And you will find sponsors that basically finance this project to put everything in production. And then, of course, last step is leveraging the value, meaning you have these solutions in practice, you have these solutions in production, people are working with it. You measure value, you make sure the value that you reach is sustainable. And that's the whole goal. So when you're not reaching this stage where you actually generate value, the project completely failed. Because, well, you invested time and money into data, you did some cool data science, but in the end, if you don't reach the value, it's failed. Okay, so now for these 4 steps, which of course are iteratively. So you don't do it like a waterfall. We heard, maybe some of you heard this talk at the other place about agile, about iterative work. So it's an iteration. And for each of these steps, I would like to tell you some stories about situations that we met a lot of times, which led sometimes to failure, from 2 perspectives. One perspective is basically the general guy involved in data science projects, for example, sponsors or project managers or any kind of stakeholders. And the other one is from the perspective of the guys working with the data, of data scientists. Because basically these are the 2 worlds that you have, and sometimes it's a communication issue between those 2 worlds. So let's start with identifying the potential. Where should you invest? Where should you do your magic with data science? So if you want to fail, don't care about analytics translation and think data and algorithms. What does this mean? In one project, and we heard this quite a lot of times, but one project, we talked to IT, and they said, hey, we have everything in place. We have a data lake with all the data that we have. We have a data scientist. We have all the tools to do analytics and AI. But business does not come up with any ideas. So they know we are there, but they don't have the problems, obviously. They don't have any problems, or they don't have problems that you could solve or support with analytics. And then we talked to business, and business said, we don't know what they want from us. They are the experts. They have the tools and the cool ideas. We have no idea what they can do, so they should come up with ideas. You hear this a lot of times in analytics projects. Today, where everyone wants to leverage data analytics, you hear this a lot of times. So the problem is here that the dedicated role of analytics translation is not defined and is not there. There are different ways how you can do this. Sometimes you have some kind of product owners that try to really understand what business wants to achieve. Maybe also what the company strategy is, where you can implement parts of the strategy with analytics, where you can solve specific pain points or problems from business with analytics. And those product owners, they go back to the data science and AI guys and find translations for this. Or sometimes you have data scientists which have a lot of domain knowledge of where they are working in and work really, really closely with business stakeholders. and come up with this analytics translation. What doesn't work is that you just throw together some IT guys, some data science guys, and some business guys, and lock them in a room and tell them, let's have a cool workshop and write some post-its and so on, and then they come up with solutions. Normally it doesn't work. So that's something, if you see this problem in your future life or in your current life, think about this role. Who in this company is doing the analytics translation? Who is capable of it? Because it's not that trivial. And also what is something that you should consider is not everything is an analytics problem, of course. So an analytics translator ideally also knows when analytics is not the right tool and what the right tool is. So for example, a lot of times when you see a problem and you think first it's an analytics problem, then maybe it's just a problem of optimizing processes, the way the processes are defined, for example. And that's something that you should always have in mind as an analytics translator. You know this picture with the nail and the hammer. From a data science point of view, if you have some data science lectures, you're always focused, of course, on the algorithms, on cool AI, on deep learning, on whatever you can do, which is really powerful. Or you are really focused on the data, you see some interesting data, and you start to think, what could I do with this? Sometimes this is the right approach, because sometimes you are in a research environment, even in a company, and you can do whatever you want. But sometimes it's not efficient enough for a project in the real world. So I had this one manager, he used to be a data scientist, was a manager at a customer. He was promoted to be a manager, and he always said, data is like Lego or any other brand that does these bricks. Give it to the data scientists, and they play with it, and they come up with cool stuff, and they do some things, and some of these things will be really innovative and really cool, and you can use it. That can work, as I said, but normally chances are that you invest a lot of time, and the project has always limited time and resources, and come up with a lot of solutions where you need to find the problem tool first to then implement it. And that's basically the wrong way around. So always try to understand the problem and then think solutions, and not the other way around. Okay? Next. So when you know about your ideas, you have a problem that you want to solve, and you agree with business, then everything is about, are we ready to tackle this problem? Do we have everything in place? And now what we really, really often hear in Switzerland, maybe it has something to do with Switzerland and the perfectionism that you have here, I don't know. But what we really often hear from a management perspective is, yeah, okay, we want to do AI and we see there's a lot of potential, but we don't have the perfect data. The data is not of high quality. We have a chaos here. We are not ready. And what they do is they start to invest on data governance, which is basically all kinds of processes and organizational stuff, to ensure that your quality is really high and that you have data owners that watch the quality of the data. And sometimes they invest months or even years in improving the data. But the problem is, sometimes it's not really clear why should we actually improve this data, because we don't know yet how it is used, what is the added value behind it. And then things become really slow, and there is only this data governance topic, and AI is far, far away. So here, what you absolutely need to do when you see something like this is to make sure that analytics starts more or less at the same times that data improvement, data governance projects starts. Because these things will learn from each other. You start to analyze data. You figure out, okay, what do I really need? Where do I have a problem with the data? Where is the signal to noise ratio wrong in the data? Where do I need to improve? And then you input this to data governance projects, and then you can really on the details work on the data where it's most valuable. And that's a completely different mindset than a lot of people have in the companies today that think, okay, let's put everything in place, let's have a huge data lake, let's have perfect data. On the other hand, of course, when you are a data scientist or someone working with data, expect good data is a way to failure. Even if the data looks good, be always aware that the data could be bad. So we had this situation where the data looked pretty good. So some data fields, everything was fine, no outliers, no missing values and so on, or little missing values. But then we learned in the discussions that some of the data was actually not showing what the data field was telling us that it shows. Because sometimes what happens in the operational world, if people work with systems, they have a fixed database, a relational database, which is not that easy to change, maybe in a legacy system. And they need to put in some information that nobody thought about before. So they just pick one field that they haven't used before. And so you end up with some information in a data field that shows or tells you a completely different story. Happens all the time. Doesn't happen with Kaggle or all these research platforms where you can do your data science projects. But in real world, it happens all the time. And when you start to work with this data and you're really proud and you have your presentation in front of the CEO and CIO and so on, and show them the results, and then someone says, hey, but this data here, it's not showing what you think it is. Not a good idea. Always expect the data to be bad quality and talk to people to find out if you're on the right track still. That's one of my favorites in proof of concepts. When you work with the data, when you have these projects, these AI projects, you have the data, you know what to do. Now, from a management point of view, in all the hype that we have about data and all the tool providers that tell you AI solves everything, there is this paradigm that's called start small, think big, or grow fast. And it happens really quickly that people start small, and then it's basically done. So it's not wrong to start small. You don't want to invest millions or invest a lot of men and women power to come up with a solution and then say, okay, it's not really in the data. It's not worth it. So you start small. But when we did this in a project, problem started when we were successful. Because we showed in a proof of concept, okay, it was about production, in food production, optimization in food production processes. And we showed, hey, there is a lot of potential. You can change some things and improve your production, reduce food waste. And then we realized that the customer did not really think about this case. Because when you have a successful proof of concept, you need to put it in production. You need to basically make a real piece of software out of the prototype. And this takes time, it costs money, and so on. And the budget was basically already gone for the proof of concepts. They didn't think about maybe what's the case if we are successful and if we want to continue. So there was no budget for this year. And basically for the next year, there were a lot of legacy and operational projects. So there was no budget either. So the whole thing died more or less. Just because of this, because people did not think from the start that a successful project will take some time and need some money. So always look at this, start small, but make sure there is the room and the budget and so on to continue and then grow fast. And from a data science perspective, let's take myself as an example here. In the PhD, I had these two groups. I had my research group, and I had these business guys in the bank. Research group was talking my language. The business guys in the bank were talking a completely different language. I was not experienced in the financial industry. So obviously what I did is I took the data and I worked with it and discussed a lot with the research people about it, found some cool solutions. But in hindsight, what I did way too little is to talk to business or to try and explain what I was doing, or even to talk about the data, as I said, interpretation of data, semantics of data. So what we see regularly where failure is at data science team is if people take the data, lock themselves in somewhere and come up with results that nobody really understands because the guys with the money, they are not data scientists. So for me, now with this 15 years of experience in these projects, communication skills are an absolutely key part of being a data scientist or working with data. So that starts with the first part, with the potential, then talking about the data, but also storytelling with your results. If you just show people a bunch of confusion matrices or whatever, many people won't understand this. So you need to translate this and train your communication skills to really show people what you're doing. There's another aspect to it with the start small. So if you're hiding the complexity from managers, they will not understand that what you're doing is not trivial and is not done very quickly, so you need some time and some budget. On the other hand, when you show all the complexity, people get bored and they don't understand what you're doing and they don't see the point. So here, communication is also key to keep living in a data science project. So if you're a data scientist, make sure you train your communication skills. And if you're working as a manager with data scientists, for example, make sure you give them the opportunity to learn about communications. Absolute key. And some of the main failures of data science teams that I see. Last point, if you made it to the last stage where you put things in production, a common pitfall is to ignore integration. So we had this interesting story where we did dynamic pricing for women's clothes. So a machine was deciding what clothes you want to reduce in the price at the end of the season in a brick and mortar store. And it was quite a big success. So there was, I think, around 15% increase in turnover in an industry where you basically have turnover going down rapidly, 20% per year. So it was a huge success. But then when you want to integrate this, you need to realize either you have lots of people in the shop that are happy to change prices every day, thousands of prices, because when you let the machine do it, you have way more price changes, dynamic pricing, or you have electronic price tags. And that's where we run into problems because the customer did not really see, okay, electronic price tags is new and well, do we really need this? And it's fancy, but we don't want to be that fancy and we want a cheap solution and so on. So the whole value, which was huge, they could have leveraged here, was in the end not really leveraged because nobody really realized there that results from data science can basically change your whole processes and have a real impact on how you do things. And another interesting point from the perspective of a data scientist, we had a project, I talked about it before quickly, it was this food production quality thing, where a data scientist came up with a very good model. How can you increase the quality of the food? That means less food waste in the production. And he came up with different impacts, different changes that you could do in production to increase this quality. But when I reviewed this, I saw that some of the recommendations that he did, some of the changes that his model recommended were either not possible to do or very expensive. So as a data scientist that plans, and you should always plan that your solution will be in production one day, already early in the process, think about what is changeable, at what cost. And sometimes if you have some features that have a high impact on the outcome, but they are not really changeable from a cost point of view, maybe it's better to ignore them right from the start. I'll show a quick graph where they show, okay, theoretically we have an impact here, but forget about it, we can't plan it, we can't do it. So focus on these things you can really change. That often gets forgotten. And I think one of the reasons why this is the case is that as a data scientist, naturally, you need to focus on the details, on the data. You need to work on really closely with the data. And you get this view on details. So at the same time, you need to have some people that do not work on these details, but see the big picture and keep everything on track. There are these characteristics, there are these psychological tests that see or that show if you are more the person that focuses on details or more a person that focuses on the big pictures. And you need both, ideally, in a data science project. Okay? So, to summarize, and of course there are way, way more problems that you could fall into, but these are some of the most important ones. Find solutions for problems, not vice versa. Do not come up with cool solutions and then try to figure out if somebody maybe have this problem. Start with imperfect data, but be aware of it. And then, of course, from an economic point of view, absolutely seminal. Make the whole journey, not just the first step. So always keep in mind, if you don't reach production stage, if you don't have value that you can measure, the project failed. And then, of course, obviously build solutions that can be used. And all of these things might sound in your ears, some of them might sound like management blah blah or not the really cool problems, but these problems cost millions. And these problems are one of the reasons why 80% fail. And even worse, that some companies start with analytics, they run into these problems and they figure out, or CIOs or CEOs didn't really work, AI is not worth it, it's not for us, so they stop doing it, and then they run later into problems, because every company that does not leverage the data it has will run into problems sooner or later because the others do it, and then you lose. Questions from your side?
Yeah, so you mentioned the importance of communication skills in data science, and as someone who's had a lot of experience in data science, how would you recommend to improve communication skills?
How to train it? Or?
Yeah, for data science specifically.
That's a good question. One straightforward thing is the whole storytelling part. So there are some groups of LinkedIn, or there are some books about storytelling. So this is something that you can directly do. On the other hand, of course, that's something that you need to gain experience with. You need to learn how do companies work. So I think what you can do, or what you should do, is when you apply for a job, make sure you have this position to learn this. So I heard, or many people that after some years in the industry, data scientists that apply for a job with us, they say we were hired and we were basically lone rangers, some data scientists that were basically put aside, or they thought, okay, we hire a data scientist and then everything will work. So they were not in this position to be integrated. They did not really learn how everything works. So try to find a company that does not need to be a consulting company. Of course it can, but it does not need to be. But if you have a data science team, or where you see, okay, there are analytics translators in place and so on, then you will learn this, definitely. So I think you can't learn it from the books, obviously. More questions?
So how do you manage to convey the proper degree of complexity to this manager that does not do that much of data science? So for example, of course, you cannot go into the details of you have applied this Bayesian neural network, whatever. But as you also mentioned, you cannot simply say, well, we are working on it, because then they will kind of assume that perhaps it's a trivial problem. So what is the balance on that?
Yeah, good question. What we normally do is, if you have a presentation, it does not look like this. It's a little bit more information than these slides, obviously. But we focus on statements that business is interested in. So there is no use in showing some complex graphs and then, for example, write, okay, 53% of your employees do not work enough, because the graph already shows this. So first of all, in the presentation itself, focus on the simple things, on the statements that people are interested in, managers are interested in. Of course, you can get a little bit more complex if you have people that you know they are interested in machine learning and so on. But at the same time, and that's the point here, in the appendix, put everything that shows how complex the process was to get there. So first of all, make everything look simple and come up with these clear statements. But when it comes to the place where you have this business case, normally you should work with some business people about the business case. You need to show and be able to show that the proof of concept is not a finished solution, and also you have quite a lot of things that you need to work more in details, where are the gaps and so on. So not show it from the start, but always be ready to show it. More questions?
I have one myself. It's probably a little bit a rude question after this talk, but we've learned about what we should avoid to not have failures. But I'm quite curious what happened to, for example, the dynamic pricing after it failed. Because obviously after this talk, this should never happen to us, but I'm curious what happened.
Mm-hmm. So with this customer, basically they had a lot of problems in a project. So this prototype that we did was basically the only success they had. But they cut costs a lot. So when it came to implementation of this, that was basically the showstopper. When they saw, okay, we need to invest in the infrastructure. So it was not done. So we weren't there in the project. We did the data science part, gave them the results, and then we weren't working with them any longer, which is unfortunate. It was not our decision. But then basically it was stopped because nobody was pushing it anymore. So they invested a lot of money and showed a lot of potential, but they never leveraged it. Yes, please.
I apologize in advance. So isn't it the responsibility of you or of the company providing the services and all the knowledge to hint to the customer that this can lead to significant investment in infrastructure, for example?
Absolutely.
So
Yes. So that's why sometimes we learned. So this whole department exists for 3 years now, and obviously we sometimes also fail. Most of the people won't tell you this, but everyone fails at some point in their time. And sometimes you just don't get to the customer with this information. And sometimes a customer decides, okay, cutting costs or whatever, and you can't influence this. But obviously, and I talk here about the failures, so we also have successes. And that's exactly our job. And that's why we focus, at least in Switzerland, we focus very strongly on these points, because very often it's not the algorithm that fails or the data scientist that doesn't come up with the right models, but it's everything around it.
Okay, I apologize in advance because I'm also going to be a little bit mean. So
Only
when
rude
you
questions here.
when you actually fail in delivering to a client, what's next?
Mm-hmm.
So what's the roadmap once you have realized that this implementation will not work or that it has already been deployed and it's not going well?
Well, you should always learn from your failures, and that's what we do, right? So sometimes we had some situations where we saw, okay, it's basically really our fault. Then we made sure that we don't take the full money for it, for example. That happened really rarely, luckily. But sometimes it's just in the collaboration or some things where we always, if there was a failure, we sit together, sometimes also with the customers, or we always get or seek feedback from the customer, and then we discuss it, and then we learn about it, then we hold talks like this to tell others and don't do the same mistakes again. So learn from your failures. You will fail many times, learn from it.
Thanks.
One last question, if there is any. Yes?
Can you tell us the success story then?
Yes. Yes, of course. So, for example, let me see what I will take. For example, dynamic pricing. So this was about flights, medical flights. So you had this company that did have medical planes, and they needed to decide what does it cost to transport a patient from South Africa to Switzerland, for example. And they had competitors. So what we built for them was a dashboard with intelligence behind to always see from external data where are the planes of the competitors, where are the planes of the company, to come up with estimation what price the customer is willing to pay. And that worked out really well. They had never this information before. They had no idea that there is information about the planes of the competitors. And that was one of the huge success stories. Another one is that if you're in Zurich and you do your tax explanation here, your taxes get analyzed by a system that we built. And they are analyzed if they are too complex to be assessed automatically, then it will get to an expert. And with the systems, I think it was last year's where we reduced the taxes that needed to be assessed by a human expert, around 100,000 tax declarations, and we are still improving this. So that's 2 examples. Okay, I think we're there. Thank you very much for your time.